Let's apply electric plasma physics ideas to real data from real filaments out in the cosmos. For example, these beauties are filaments at the center of our galaxy, viewed with the South African Meerkat radio telescope. About these newly discovered filaments of superheated plasma, I don't think I even need to say it, but I will. Headline: Scientists were surprised to find thin filaments of highly energized plasma radiating like a banshee in the radio bands. How surprising, when you only have gravity and magically appearing magnetic fields in your astrophysics toolbox. In the case of these galactic center filaments, mainstream is forced to admit that there must be powerful magnetic fields compressing the filaments. But as usual, mainstream is struggling to account for the origin of the magnetic fields. Okay, enough of that old trope. Let's dive in with electric cosmology and talk numbers. What's the math we're going to use? We are going to use what's known as the Carlqvist relation. The left side is the compressive forces, gravity, and the inward pinch from the magnetic field created around an electric current. The right side is the expansive forces, thermal pressure and magnetic field pressure. I will admit that magnetic field pressure is not so intuitive to me. The idea is that it takes energy to compress a certain amount of magnetic field into a smaller volume. There are, of course, other terms we could add, such as electrostatic forces or some double-layer geometries, but the goal here is to start somewhere that reasonably includes the electric currents that create the magnetic fields. What we are looking for then is data from the literature about the density of the filaments, which will play into the gravitational and the thermal pressure terms, the temperature of the filaments, which will play into the thermal pressure term, the magnetic field strength in the filaments, which will determine the electric current and also contribute to the magnetic pressure, and lastly, the radius of the filaments, which will enter into all the terms of the equation. Here is a table of parameters that I adopted for galactic core filaments, along with the reference sources and some notes about why I chose the value that I did. Putting these values into the Carlqvist relation and solving for electric current for the galactic center, we get 7 times 10 to the 16th amps flowing through those filaments. This is, for me, unimaginably large. The aurora of the Earth are powered by billions of amps constantly going into and out of the poles of the Earth. I think that by now most of us realize that these currents are involved with creating the magnetic field of the Earth itself, rather than the simplistic and sadly lonely picture of the Earth purely creating its own magnetic field all by itself, disconnected from its larger world. So our calculation we just did for the center of the galaxy said that there are filaments with 10 million times larger current than is flowing through the Earth. Where do these galactic currents come from? We really don't know. I do know that we need the correct categories for thinking about this. We must see the galaxy as living. We must see the galaxy as a citizen of a larger world in which it is conceived, born, lives, has children, and dies. We must ask what are the functions of these filaments in the body of the galaxy. We will not understand the filaments if we seriously believe they arose randomly and to serve no function. Your body is filled with all kinds of filaments, vessels, tubes. Some connect, some transport, some communicate, controlling instructions. As the astronomical data continues to pour in, we are being forced to admit that yes, also our galaxy is unimaginably complex and structured. The body of the galaxy is just as complex as your body, and your entire body is just as complex as a single cell in your body. Complexity has nothing to do with size. All cosmoses, large and small, have the same degree of complexity. Getting back to numbers, we will collect data from 3 different size scales. 1, the interstellar medium inside our own galaxy. 2, the galactic core of our galaxy. And 3, the intergalactic filaments upon which hundreds or thousands of galaxies live. So looking first at the interstellar medium, we will look at the Musca filament. We will look at the Taurus molecular cloud B211. We will look at the Taurus molecular cloud 1506. And we will look at the molecular cloud IC 5146. We will also look at the Pipe Nebula. Now, from our galactic core, we will choose 2 of the ones I showed at the beginning. First, what's sometimes referred to as the Meerkat radio arc, and then the boringly named Meerkat G 0.2 plus 00, meaning basically it's the center of our galaxy. Now, from the super large scale of the intergalactic medium, we will take the Coma A1367 filament and the A399 to A401 bridge, which is a bridge between galactic clusters. And also some filaments from what's referred to as the Perseus-Pisces filament. We will put all the assumed values into a table along with the calculated electric current needed to balance all the forces. It's a whole lot of numbers, so it's probably better if we make some plots. We will compare the value of the derived electric current to the other measured values. So first, a plot of how the electric current in the filament relates to the magnetic field present in the filament. You can see I've arranged them by color. So the green color is the intergalactic medium, the orange color is our galactic core, and the blue color is the interstellar medium. And then next, how the current relates to the mass density in the filaments. And then lastly, how the current relates to the temperature in the filaments. I find it very satisfying to see the 3 size regimes are obviously clumped together. Now, if the blue, green, and orange dots were scattered all about the plot randomly, I would seriously doubt the results. But seeing each regime occupying its own section in the parameter space lends confidence to our approach. And I'm still pondering the meaning of the 3 plots. It's a lot to take in. I will point out that for all these, my calculations show that the effect of gravity is quite small compared to the other forces, less than 10%. In the case of the filaments in our galactic core, this is admitted by all. The mass densities are simply nowhere near what is needed to constrain such hot filaments. But in the case of the interstellar medium and the intergalactic scales, I will let my analysis here stand as a contribution of whether or not gravitational collapse really can explain the formation of such filaments. I find the numbers presented here on their own to be largely incomprehensible. We humans are born and raised on a cold, dense planet. We have nothing in our experience that relates to these temperatures and densities. Luckily, as above, so below. There are themes that resonate up and down the great chain of being which we call our universe. We Earth beings inhabit a single layer in a Russian doll arrangement of worlds within worlds, and all the worlds are filled with living, breathing creatures. We need to blend the Russian doll model with that of a giant tree that branches out smaller worlds underneath larger. Imagine a tree where each smaller branch was a step down into much cooler temperatures and much more dense matter. In this essay, I focused on plasma filaments. Filaments perform similar functions, whether we are looking at the body of a galaxy or the body of a liver cell. Filaments provide structural integrity, are highways for transportation, and are pathways for signals of control. The center of our galaxy is a very energetic environment, and yet great nature must somehow still produce filaments. And we see that 10 to the 17th amps, a particle per cubic centimeter, 5 million degrees, and 10 to the minus Tesla magnetic field is the combination needed. I don't know that the individual numbers mean much. Certainly, the relationship between them is important to achieve the required result.